Before seeing the advanced concepts of memory management, let's first see the basics, okay? Some basics of memory management. First point which you might ask is, what is meant by a memory? Okay? We have various levels of memory, right? We have one thing is registers which are closest to CPU. We have RAM, we have hard disk, and also we have something called as cache, which is not important for this course. So let's forget about cache memory. We have registers, we have RAM, we have hard disk. Now what do they really mean by memory? All these are memory, right? But by convention, whenever they use the word memory, it means that it is a RAM, okay? Random access memory, okay? It has been used as a convention. Whenever they use the word RAM, it means memory. Whereas hard disk, they use the word disk, okay? In case if they use the word disk, it means hard disk, okay? Why do you need registers? CPU uses registers in order to take some value, take some word from the RAM. Let's see about word a bit later. CPU actually fetches something. See, by fetching, I mean copying, okay? Let us assume this is what CPU is actually taking from the RAM and then placing it in the register, and then it will execute, okay? That is the only purpose of registers. Registers are very close to CPU, and so accessing them is very fast. It is the fastest memory in our entire computer, okay? There is no memory which is faster than registers in our computer because it is very close to CPU, okay? See, so we say this as CPU registers, okay? We say these registers as CPU registers, okay? So any operation you take, our CPU will take the data into the register and then it will execute it, okay? Fine. Now, one important convention which most of the textbooks actually follow is they assume that size of one register is one word, okay? Now let me tell you what is meant by word, okay? See, our entire memory RAM has been divided into words, okay? It is called as word. Within a word, we can place an instruction or we can place data, okay? See, in our computer's memory, we store only two things. One is instruction. What is meant by instruction? Instruction is nothing but a part of a program, okay? You can think of it like a line of a program. See, line of a program and instruction are quite different. It's not too much different, it is slightly different. Let's see it a bit later. As of now, think that an instruction is nothing but a line of a program, okay? We write programs, right? It has a lot of lines, out of which you can think of this program has 4 lines, okay? 4 instructions, you can think of it like that, okay? Fine. Now, apart from instruction, we use some other thing called as data, okay? These are the two things which we store in our computer's memory. It is not just about RAM. It can even be registers, or it can even be hard disk. These are the two things which we store in our computer's memory, okay? See, data means it can be either a number, or it can be a letter, it can be a sentence, or it can be an image, or it can be an audio file, video file, anything you take, we say this as data, okay? And everything will be present as ones and zeros, right? Doesn't matter whether it is a letter A or it is an MP3 file, okay? Anything you take in place it in a RAM, it will be in ones and zeros. How? Because we already know that, right? Any program will be compiled, which means using compiler we convert it into machine code, ones and zeros, and then we place in hard disk, and then it is actually coming to RAM, okay? So we already know that any data which is present in our RAM should be in ones and zeros. It is not just RAM, even in hard disk or register or anything, okay? It will be present in ones and zeros. So two things which can be present inside our computer's memory, not only memory, registers or hard disk or anything, are nothing but one is instruction, another thing is data. We can also say this is program. How? Why? Because a program is a collection of instructions, right? Fine. Now every word of our computer's RAM will have either instruction or it will have data. See, it really depends on implementation. For example, some computers use 2 words to represent an instruction, okay? Some computers use 3 words to represent an instruction. But as of now, let's assume that for every word takes exactly one instruction, okay? It is just for an assumption, but most of the textbooks follow this convention, okay? They assume that every word of our computer's memory will have exactly one instruction, okay? Fine. Now every word will be addressed, okay, every word in our computer will somehow be addressed, okay. Now how it is addressed is, let us assume it is addressed. Now one more important point I want to discuss is what will be the size of a word, okay. What will be the size of a word? It again depends on implementation. For example, some computers use one word equal to 4 bytes. Some computers use one word equal to 8 bytes. Okay, it really depends on implementation. But it will always be a power of 2. Okay, one thing is size of RAM will definitely be a power of 2 in today's computers. Similarly, size of a single word will also be a power of 2. Okay, similarly, size of hard disk will be a power of 2. Similarly, size of a single register will also be a power of 2. 4 bytes, 8 bytes, 16 bytes, 32 bytes, something like that. Now, every word, see, this is a word, right? This is a word, this is a word. Every word of your for computer's RAM will have an address, okay? Will have an address. For example, we always start off with 0, okay? We don't start with 1, we start with 0. And then we go on till 1, 2, 3, 4 and so on. Every word of your computer's memory will be actually addressed, okay? See, whenever I use the term 1, 2, 3, does that mean it is actually numbered in binary decimal format? No. The addresses will also be in binary format, right? That everything in our computer is in binary, and even the addresses we can represent in binary format. For example, the number 4 can be represented as 100, right? It can also be represented as 0100. This is also 4, right? We can also represent this as 00100, right? This is also 4. Now, which one should we be really using? Which means what I want to ask is how many bits will the address of a word in the RAM will be? Okay, how many bits will the address be? That's what my question. It can be either, it can be any, it really depends on the size of the RAM. Okay, it really depends on the size of the RAM. We have already seen that with n bits, we can represent, we can have 2 power n numbers. Okay, with n bits we can have 2 power n numbers. Now, in order to represent, I have already told that the size of a RAM will be a power of 2 and also the number of words in our computer will also be power of 2. Let us assume our RAM is having 2 power m words. Okay, our RAM is having 2 power m words. Why? Because it will be a power of 2. Now, in order to represent this 2 power m words, we need m bits, right? We have already seen it. With m bits, we can represent 2 power m words. I can also say it as, in order to represent 2 power m bits, I need a minimum of m bits, okay? I need a minimum of m bits. Now, see, we always take the minimum value, okay? We don't need to have extra bits and waste our computer's memory, right? So, what we will be having is, we will be having m bit addresses, okay? We will be having m bit addresses. For example, if m equal to, let us assume if m equal to 32. In that case, the first one will be 32 zeros, okay? And the second one will be 31 zeros followed by a 1. The next one will be 30 zeros followed by a 1 0. That is how our computer's words will be addressed. Okay. Now, how will CPU will actually ask for a word from the RAM. Okay. It will ask for a word from the RAM, and the word, how will it ask is, it using addresses. Okay. Using the address. For example, if CPU needs this word, okay. See, we have seen that CPU will always be executing a program, right? Now, why am I saying that it is actually asking for a word? Actually, CPU always asks for a word, okay? CPU will never ask for a program. See, CPU will always ask for a word, okay? It will never ask for a program, or it will never ask for a data, it will never ask for an instruction or whatever it is. CPU will always ask for a single word. Now, in case if CPU wants to get this word, what it will do is, it will give the address 4 to the RAM. Okay, it will give the address 4 to the RAM, and RAM what will do? It will do is, it will take this word's data, a copy of this data, and then it will give it to the registers. Okay, now CPU will take this data and then it will process it. Okay, see, it is the data is actually copied, which means the data which is at word 4 will be present in RAM as well as it will be present in registers. That is why I am saying that this word will be copied from the RAM and then it will be pasted inside the registers, so that our CPU can process the data or instruction. Okay, anything is fine. So this is very important. Okay, this is the basics of understanding the RAM. Okay, now one question you might ask is, how does the CPU request for a word? Okay, I told that CPU requests for this word using the address, and so it will get the data into the registers, and so it can process the data, right? Now how will the CPU request the word as well as how this data is moved into the register? For that they use something called as bus. Okay, they use something called as bus. See, bus is nothing but a collection of wires. Okay, a collection of wires which are used to connect all the devices of our computer. Okay, so let us assume, you can think of it like our register and RAM are connected by wires. Okay, they are connected by wires. So any data, so when CPU requests for a word, it sends the address through something called as address bus. Okay, address bus again is see, all these are concepts of computer organization architecture. They are no way needed in operating system. I can challenge you. Okay, these topics we will never be speaking about. Just I am giving a rough overview. Okay, these are important. This addresses, instruction, data, all these are important. But coming to this, that address bus, data bus, all this we actually study more in detail in computer organization and architecture. Okay, right now even if you didn't understand, fine, you can skip this. Okay, fine. Now by bus, what I mean is it is a collection of wires. Okay, so our registers of CPU will be connected to RAM through a set of 3 wires. Okay, you can think of it like it is a set of 2 wires. Okay, one wire is used for sending the address. Okay, it is also called as address bus. Okay, address bus is a collection of wires through which our CPU will be able to send the address to the registers. Similarly, we have something called as data bus. Okay, data bus is again a collection of wires which are actually used in order to send the data from RAM to CPU's registers. Okay, so using this bus, our CPU is able to communicate with the RAM and get the data. Okay, this is what is actually happening in our RAM, in the RAM of our computer. Okay, and one more important point, how many bits do we need in order to address the RAM? A word of our RAM is nothing. It really depends on number of words we have. Okay, in case if our RAM size is 2 power m words, then we need m bits to address the RAM of our computer. Address a single word of the RAM of our computer. Okay, fine. So this is the basics of memory management. Okay, let's get into it. See, if you didn't understand it exactly, don't worry. We are going to get into concepts right now. Okay, you will be able to understand all these things in a very perfect way. Okay, fine.